The Starliner is leaking helium, thrusters are failing, astronauts are stuck at the space station, and the prognosis is dire. The only way they can return is if SpaceX's Crew Dragon can rescue them and bring them home. But is it really? Let's talk about that.
Go for deploy. With to the right level. Contact light. Eagle has landed.
Hey friend, Tori here from Overlook Horizon, and welcome back. If you're new to the channel, consider subscribing to see more. The Starliner Crew Flight Test, or CFT mission, launched on June 5th, 2024, carrying NASA astronauts Butch, Wilmore, and Suni Williams, and it has encountered technical issues, including helium leaks and thruster malfunctions. Now, initially, the flight was scheduled to return on June 14th. That was then pushed to the 22nd and then to the 26th, but now the mission has been extended to at least July 2nd to allow NASA and Boeing to thoroughly assess and address these issues. But should we be talking about a rescue mission? Do we need SpaceX to save the day? Well, first, let's dive into the issues. Helium leaks. Helium is crucial for pressurizing the Starliner's propulsion system. In spaceflight, pressurizing the propellant tanks with an inert gas like helium ensures a stable and consistent flow of propellant to the thrusters. This is essential for the reliable performance of the thrusters during docking, undocking, and other maneuvers like deorbiting. Helium is stored in high-pressure tanks within the service module, and it's regulated through a series of valves. This regulated helium backfills the fuel tanks and maintains optimal pressure in those tanks, which contain hypergolic propellants like monomethylhydrazine and nitrogen tetroxide. These propellants ignite on contact, providing reliable ignition without the need for an ignition system. As the fuel and oxidizer are used, helium is pumped into those tanks to keep the pressure up. Helium leaks are relatively common in spaceflight due to the unique properties of helium and the high-pressure systems required to store and utilize it. Helium is the second smallest molecule in the universe with a very low atomic mass, allowing it to easily escape through even the smallest imperfections in seals and materials. In spaceflight, helium is typically stored at extremely high pressures, often around 3,000 psi, to ensure that it can be efficiently used to pressurize propellant tanks and other critical systems. This combination of tiny molecular size and high storage pressure creates a challenging environment for maintaining completely leak-proof systems. The high pressure increases the driving force for helium to escape through any potential pathways, such as microcracks, welds, or imperfect seals, making helium containment an ongoing engineering challenge in the aerospace industry. Now, helium leaks are not unique to the Starliner. They are a common challenge in spaceflight that many rockets have faced and successfully managed. For instance, the Ariane 5 rocket experienced helium leaks due to issues with pressure regulators in its helium pressurization systems, and yet it has successfully completed its missions with these leaks. Similarly, several Atlas V rockets have encountered minor helium leaks during pre-launch testing and countdown procedures, which were either resolved or they were deemed non-critical, allowing the launches to proceed as planned. These are just a few examples that illustrate that helium leaks, while common, are often manageable and do not necessarily pose a significant threat to mission success. Now, currently, there are 5 helium leaks that have been detected on Starliner. One was detected pre-launch, which was considered minor and not a threat to safety, and 4 more have since been detected after launch. These leaks are located in the service module's pressurization system, which includes the high-pressure helium tanks, pressure regulators, and distribution lines. The service module housing these systems is jettisoned before re-entry, meaning these issues won't really impact the crew's safe return. However, understanding the root cause of these leaks is essential for future missions. That brings us to the second problem: thruster issues. The reaction control system thrusters, or RCS thrusters, are small rocket engines used to control the spacecraft's attitude, orientation, and position. They are critical for fine-tuning the spacecraft's trajectory during docking with the ISS, undocking, and re-entry. Now, Starliner is equipped with 28 RCS thrusters, each providing about 100 pounds force of thrust. These thrusters are arranged in clusters around the service module to provide redundant and balanced control in all 3 axes: pitch, yaw, and roll. During the rendezvous and docking phase, 5 out of the 28 RCS thrusters experienced malfunctions and were automatically shut down by the Starliner's onboard computer system. These thrusters are part of the vehicle's primary control system for attitude adjustments and precise maneuvering. 4 of the malfunctioning thrusters were successfully brought back online through troubleshooting and system resets, ensuring sufficient redundancy for docking and planned undocking maneuvers. Now, since then, while they were docked to the ISS, a hot fire test was conducted on June 15th. This validated the operational status of the remaining thrusters needed for post-undocking maneuvers and the critical deorbit burn. This test involved firing the thrusters to ensure that they could provide the necessary performance under flight conditions. So, what's going on? Well, let's put all this into context. NASA and Boeing have determined that these issues do not pose a significant safety risk. The crew module itself, which contains life support and re-entry systems, is unaffected by these issues. The crew module's life support systems include air revitalization, carbon dioxide removal, oxygen generation, temperature and humidity control, waste management systems, and all this ensures that there is a habitable environment for the crew. Now, the decision to delay the return is precautionary, allowing engineers to analyze telemetry data and conduct further testing to ensure that all potential risks are understood and mitigated. Remember, the service module doesn't return. Any good engineer is going to want to run through as many tests as they can and collect as much data as they can while the service module still exists. Once the decision is made to return, the service module will be intentionally destroyed, along with the ability to further test or collect data. So none of the issues that have occurred so far indicate any safety concerns or that the crew would have any major problems returning in Starliner. So what could go wrong? All right, let's play the what if game. What if the helium leaks get worse? If the helium leaks were to worsen, the primary concern would be maintaining adequate pressure in the propellant tanks. The current leaks are very minor and within acceptable limits, but engineers are closely monitoring the system. Redundancies in the pressurization system, including multiple helium tanks, multiple pressure regulators, provide a safety buffer. Even with additional leaks, there is enough helium on board to maintain necessary pressurization for the return trip. Starliner currently has 70 pounds of helium on board, and they only need 7 pounds for the return trip. Okay, so what if more thrusters fail? Well, the Starliner has a high level of redundancy built into its thruster system. With 28 RCS thrusters, the spacecraft can maintain control even if several thrusters fail. As of now, only one thruster has completely failed, and it'll be left off for the remainder of the mission. But engineers have successfully brought the other 4 malfunctioning thrusters back online, and a successful hot fire test has validated that those remaining thrusters are operational. In the unlikely event of additional failures, there are still sufficient operational thrusters to safely undock and deorbit. Alright, but why not a rescue mission? Alright, so if we're going to have a rescue mission, we have to assess the risk. Launching a rescue mission with another spacecraft, such as the Crew Dragon, would involve significant risks and an enormous logistical challenge. Currently, there is no Crew Dragon capsule that is immediately ready for launch. The turnaround time for preparing a Crew Dragon capsule is roughly 5 months, according to Steve Stitch, who's NASA's Commercial Crew Program Manager. Now, Capsule 206, known as Endeavour, is currently docked to the space station, and this cannot be used for Starliner astronauts to return because it serves as a crucial lifeboat for the ISS crew that arrived in this Dragon, ensuring that they have a safe haven or a way home in case there's an emergency on board the ISS. Capsule 207, known as Resilience, could be made ready, but it's been modified for the Polaris Dawn mission, and it currently lacks docking hardware. Capsule 210, known as Endurance, returned from the Crew 7 mission on March 12th, and it's planned to launch Crew 9 in August. Capsule 212, known as Freedom, returned from the Axiom 3 mission on February 9th, and it's planned to launch Axiom 4 in October. And Capsule 213 is still under construction, and we don't really know where it is in its readiness. Now, given these statuses, Capsule 212 might be a good option, but I seem to think Capsule 210, known as Endurance, would likely be the only capsule that could be prepared for a rescue mission, which would require a significant disruption to the planned Crew 9 mission. SpaceX would need to rush the preparation of this Crew Dragon for launch, including making new spacesuits for Butch and Suni, or they'd have to build and test an adapter to use their existing Boeing flight suits in a Crew Dragon. One of the most significant logistical challenges would be undocking a current vehicle to make room for a rescue vehicle at the ISS. The ISS has limited docking ports, and to dock another vehicle, one of the current vehicles, either Endeavour or Starliner, would need to be undocked. For safety reasons, this undocking is generally only done with astronauts on board the capsule. Undocking Starliner would not be a viable option unless it's to immediately replace it with a safer alternative, but if Starliner is in such bad shape that we need to replace it, are we really going to risk the space station by undocking it without a crew and then assuming it will safely navigate away from the ISS? So that leaves Crew Dragon Endeavour to do the undocking. They'd have to move to a safe distance from the ISS and wait until the rescue vehicle has successfully docked, but then what? Do they just go home? Do they wait hours until the new Starliner can leave with Butch and Suni before it goes and docks again? The entire process of preparing a new Crew Dragon capsule, making the necessary suit modifications or adaptations, and safely managing the undocking and docking maneuvers is incredibly complex and very time-consuming. I mean, realistically, it would take months to prepare such a mission. It could be done. It would take months, during which the situation with Starliner could likely be resolved with more straightforward approaches. These logistical challenges highlight why something way more severe than a few helium leaks would be required to justify a rescue mission. The potential risks and operational disruptions involved are considerable, and NASA and Boeing's current approach of thoroughly analyzing and addressing the existing issues is the most rational and safe course of action. Now, I can hear all the Boeing naysayers already that maybe I'm being too lenient, so I will add one criticism. One area where I think NASA and Boeing could improve in this situation is the frequency and transparency of their updates. The lack of regular information is fueling wild theories and speculation online, which could be mitigated by more frequent and detailed updates. Clear and timely communication would really help keep the public informed and grounded in facts, reducing some of this unnecessary panic and misinformation. So maybe NASA and Boeing should do better there. Finally, it's important to note that all of this analysis is based on the current information available today, June 22nd. If ongoing tests reveal there are more severe issues, we should be ready to reevaluate our opinions and plan accordingly. However, let's form our opinions based on the data at hand, like proper scientists, and avoid jumping to conclusions without solid evidence. The Starliner crew is safe, and NASA, along with Boeing, is taking all the steps that they should be taking to ensure their safe return. The issues at hand are being thoroughly analyzed and addressed, and these test flight experiences provide valuable insights for future missions, helping improve the design and reliability of Starliner for their operational crew rotation flights. So what do you guys think? Am I out of my mind? Am I being too lenient on Boeing? Let me know what you think about this situation in the comments down below. All right, that's gonna do it for me. My name's Tori. This is Overlook Horizon. I'll see you in the next video. Goodbye. And that's right. Literally. Come on. Safe return.